Good morning, everyone, and welcome back to another gorgeous day. Today we're going to be looking at adding and subtracting fractions with unlike denominators, meaning that the denominator, which if you remember, a denominator is our downstairs neighbor, it's the bottom number in a fraction, are different. So let's take a look at some examples using a couple of different word problems. Watson MST has 2/8 of a garden planted with pumpkins and 1/3 of a garden planted with squash. How much of the garden is planted? So the first thing I need to do is I need to determine what am I doing with these. So they've told us that 2/8 of a garden is planted with pumpkins. 1/3 of a garden is planted with squash. How much of the garden is planted? So this tells me that they're giving me a piece, they're giving me another piece, and they want me to add them together to figure out what the total is. So looking at this one, I've already created my fraction bars with 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3 pieces. Now, I prefer to use matte pencils when I am working with fractions, just because I find it's easier and you have more options, and it's easier to break them apart once you've filled them in. So I'm going to choose 2 colors. Doesn't really matter which colors I choose. I'm more going with 2 that I have enough lead on them. So I need to know that I need 2/8 of a garden planted with pumpkins. So I'm going to shade that in just to give my brain that color connection. So 2 out of 8. So here is my 2. So there's my 2/8 planted with pumpkins, and 1/3 planted with squash. There we go. Now, when you're adding or subtracting fractions and the denominator, meaning the number of pieces, is different, that's going to be a problem. And I want you to stop and think to yourself, why can we not add fractions with unlike denominators without doing something first? Why is the different number of pieces a problem? Now, if you said because they're different sizes, you would be correct. We need to add pieces that are the same size. So this means that we're going to have to change the total number of pieces to make them equal. So to do this, step 1, I need to make both fractions have the same number of pieces. So this means that the denominators must be equal. In order to do this, we are actually going to have to create equivalent fractions. Now, a lot of people would say, well, how do you know how many pieces you're going to do? I'm going to make this a little more simple. Our first garden has 2/8. Our second garden has 1/3. Okay. I need to use the denominators that I already have. Think to yourself for a moment, what is 8 times 3? 8 times 3 is 24. So this means for every piece of each fraction, we need to figure out how to break them into smaller pieces so that the entire bar equals 24. For this fraction, I know that 8 times 3 equals 24. So each of these boxes of my fraction bar, I need to split into 3 pieces. Now, I like to think of these as multiplication arrays. I'm actually going to come through and draw lines sideways because I now have 8 pieces across, 3 pieces in rows, and I now have 3, 6, 9, 12, 15, 18, 21, 24 pieces. So my new equivalent fraction is 1, 2, 3, 4, 5, 6 shaded out of 24. Now for my second fraction, I still need to somehow turn this into 24 pieces. So that means that each section needs to be broken into 8. Now I could go through and do this a couple of different ways, but in my mind, I know that this needs to be 8, this needs to be 8, and this needs to be 8. So there's 2, there's 4, and that makes it 8. So 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So now I'm just going to carry this line all the way down. There's 2, and that makes 8. So those 2, and that makes 8. So I now have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I have 24 pieces, and 1, 2, 3, 4, 5, 6, 7, 8 of them are shaded. Now we need to add them together. You have a couple of different ways of doing this. I prefer to take the shaded pieces from one and move them into the other. I feel like that just makes it more straightforward of exactly what I'm doing, showing that I'm adding. So I am going to take these 1, 2, 3, 4, 5, 6. I'm going to circle them with a different color, and I'm going to move them to my other fraction because now they're the same size pieces. There's 24 in each bar. So there's 1, 2, 3, 4, 5, 6. And now I can count them. 2, 4, 6, 8, 10, 12, 14. So 2/8 plus 1/3 equals 2, 4, 6, 8, 10, 12, 14 out of 24. And because we can reduce this fraction, we can simplify it, I'm going to go ahead and do so. So if I'm thinking to myself, well, I need to get one of these numbers, my numerator or my denominator, to a prime number. Well, I know that if I divide 14 by 2, that equals 7. And that's going to give me a prime number. So I'm going to tell myself 14 divided by 2 and 24 divided by 2, because whatever you do to the top, you must do to the bottom. 14 divided by 2 is 7. 24 divided by 2 is 12. Now you may be wondering, well, Ms. Pike, how do you show this here? I got you. I promise. So we divided by 2, correct? So this means that we need to create new groups with 2 pieces in each group. So there's 1, 2, 3, 4, 5, 6, 7. And if you continued making these groups, because remember, you also divided the denominator by 2, so that means that every 2 pieces becomes 1 group. We now have 1, 2, 3, 4, 5, 6, 7 shaded out of 8, 9, 10, 11, 12. So our final answer would be 7/12. Okay. All right. Let's take a look at the next question. The Amazon Alexa has 1/2 of a full battery. 1/4 of the battery is drained playing music. How much battery power is left? So we have 2 fractions. We've got a battery that is half full, and then we're taking a chunk away because the battery is being used. So I'm going to label this as the total, and this is going to be what I'm taking away. Okay. My total equals 1/2. That's the battery power that I'm starting with, and what I'm taking away is 1/4. So once again, we start by coloring in our fractions. Doesn't matter what colors you use as long as it makes sense to you. So I'm going to start with 1/2, so that means 1 out of 2 pieces shaded. And then my second fraction is the 1/4 of the battery that is drained. So that means 1 out of 4 pieces. So 1 piece out of 4. There we go. All right. Now, this time I'm taking away a piece, so I'm subtracting. So I'm going to be taking this 1/2, and I'm going to take away 1/4. But again, my denominators are not the same. So just like this step, you have to make both fractions have the same number of pieces, which means the denominators must be equal. So I am going to use my 2 fraction bars to create this model. Well, I know that 2 times 4 equals 8, and 4 times 2 equals 8. So I'm going to turn each fraction, 2 times 4 equals 8, into a fraction with 8 pieces. If I've got 2, I need to turn it into 8. That means that I'm multiplying by 4. So each section of this fraction bar is going to be split into 4. I'm going to go ahead and do, there's 4 and 4. So now instead of 1/2, I have 1, 2, 3, 4 out of 8. To turn 1 into 4, you multiply by 4. To turn 2 into 8, you multiply by 4. Whatever you do to the top, you must do to the bottom. Whatever you do to the bottom, you must do to the top. So we multiplied by 4 and multiplied by 4. All right, now, in order to be able to take this 1/4 away, I also have to turn it into 8 pieces. It has to be equal. So to turn 4 into 8, I need to multiply by 2. So that means that each of these pieces is going to be split into 2. There's 2, 2, and 2. And now if you look at this, don't these bars look a lot alike? Almost exactly. Even though we drew in the lines, they're almost in the exact same place. Now I have 2 out of 8. So now our equation has changed. Instead of 1/2 minus 1/4, we have 4/8 minus 2/8. Now we simply need to subtract. And you're probably thinking, well, Miss Pike, how do we subtract on fractions? I need to take 2 pieces out of 8 away. So if this is my total, I'm going to circle the pieces that I need to take away, and I'm going to put a big X through them. I am taking them away. They are no longer there. Now I have 2 pieces out of 8 left. And once again, if we simplify this fraction, we need to get one of these numbers to be a prime number. Well, I know that 2 divided by 2 equals 1. And even though 1 is neither a prime nor a composite, you can't get any smaller than that. So I'm going to divide both the numerator by 2 and the denominator by 2, which means that I'm going to group these into groups with 2 pieces in each. So there's 1, 2, 3, and 4. So now I have 1, 2, 3, 4 pieces total. And I took this shaded piece away, so that means that I still, with grouping them, I now have one group shaded out of 4. Because 2 divided by 2 equals 1, 8 divided by 2 equals 4. So 1/4 is our final answer. All right, we are going to be continuing these examples in class with 2 more word problems that we will do together. So I hope that this has given you a good starting point on adding and subtracting fractions with unlike denominators. I promise you we're going to be doing more of it in class. If you have questions, let me know, and have a great day, guys.